Collaborative filtering method is used to predict how likely would a user prefer a given item so that based on these predictions we can recommend relevant items to the user. There are two types of collaborative filtering, which are user-user and item-item, and the idea for both is very similar, that if you understand one, the other one is quite trivial. So let's discuss the user-user collaborative filtering. Let's say we have a user X and a movie M, and we want to predict what rating would X give to M in order to gauge whether we should recommend this movie to X or not. To find that, we will look at the users which are similar to the user X from our database. We will then see what ratings were given to this movie M by other users who are similar to X, and then we will predict that X would give the same rating as the average rating of other users who are like him. This average can be a simple average or a weighted average, where the weights would be the similarity between X and the user. So in mathematical terms, predicted rating of X for movie M would be equal to sigma similarity between X and Xi into rating given by Xi to movie M divided by the sum of similarity between X and other users Xi, where I is from 1 to n. It now boils down to how do we find the similarity between two users. One of the commonly used similarity metric is cosine distance. Basically, cosine distance between X and Y can be visualized as cosine of the angle between the vectors X and vector Y. So let's say if the angle between vector X and vector Y is theta, then we know that the dot product for vector X and vector Y is written as magnitude of X into magnitude of Y into cosine of angle between them. So the cosine similarity between X and Y is simply the dot product between X and Y divided by magnitude of X and the magnitude of Y. If this angle is 0, then since cosine of 0 is 1, the similarity metric will be 1, representing that X and Y are 100% similar. If this angle is 90 degrees, then the similarity is 0, which means X and Y are not related to each other at all. And if this angle is 180 degrees, then the cosine similarity is -1, which indicates that X and Y are completely opposite and not similar at all. So the cosine similarity values varies from -1 to 1, where -1 represents the lowest and 1 represents the highest similarity level. Let's consider an example. Here we have 4 users A, B, C and D and 7 movies. Let's say we have to predict what rating would user A give to the movie Harry Potter 3, that is HP3. For that, we would have to find users similar to A, and to calculate the cosine similarity, we would first have to somehow fill in the missing values to calculate, to use the vectors for A, B, C and D. Now we have 3 options to fill the missing values. Either we fill the missing values with zeros. The problem with this is that a value of 0 represents that the movie was disliked by the user, but instead, since the movie has not yet been rated by the user, we would like to assume a moderate value rather than 0. Another idea is to fill the blanks with the average rating, that is 3. The problem with this is that some users are lenient while others are strict. So if we have a user who mostly gives a 4 or 5 to all the movie ratings, a rating of 3 for him would again assume that the user did not like the movie. To avoid that, the other idea we can use is to fill the blanks with user specific average rating and then take the cosine similarity. So in this case we can see that the average for user A is 4 plus 5 plus 1, that is 10 divided by 3. So we will fill all the missing values for user A by 10 by 3. Similarly, for user B, the average rating is 14/3. For user C, the average rating is 11/3. And for user D, the average rating is simply 3. This idea is very convincing, but it still has a problem, and that is we are only interested in relative preference of movies by the user to find the similarity between two users. To explain it further, let's assume we have only two users X and Y, and we have only two movies M1 and M2. Let's say X has ratings 1 and 2 and Y has ratings 3 and 4. Ideally, since the relative preference of movies for both the users is same, the similarity between them should be 1. But to do that, what we need to do is we need to mean center the users, that is subtract the mean of the user ratings from all of its ratings before finding the cosine similarity. This metric is known as centered cosine or Pearson correlation. So in this case, mean for users are 10/3, 14/3, 11/3 and 3. Once we subtract these means, we get the second table in the slide. Then we take the cosine similarity with A of all other users. So in this second table, we can assume that all the values are 0. Now the similarity between A and B would be 0.09 using the second table. Similarity between A and C would be minus 0.56, and similarity between A and D would be simply 0, since dot product between A and D is 0. So the only user we have somewhat similar to user A is user B, and we can simply take the rating of B as rating of A, which is 4. So if we take the weighted average, we will simply be dividing with 0.09 and multiplying by 0.09, which will give us the rating of 4. Of course, this is a toy example, and in real we would have many more users similar to A to take the weighted average. To formalize the cosine similarity, we notice that cosine similarity is not invariant to shifts in data. That is, cosine similarity of x and y is not same as cosine similarity of x plus 1 and y. And to avoid that, we use Pearson correlation. Pearson correlation or centered cosine between x and y is calculating by first subtracting the means from x and y and then taking the cosine similarity. Cosine similarity can also be written in terms of covariance and standard deviation by noting that cosine similarity between x minus x bar and y minus y bar is simply the dot product between them divided by their magnitudes. And if we divide numerator and denominator by n, we can see that the numerator here is nothing but the covariance between vectors x and vector y, and denominator is nothing but the standard deviation of x and standard deviation of y. Hence, cosine similarity can also be written in terms of covariance of xy divided by standard deviation of x and standard deviation of y as shown. Now, as I mentioned in the beginning, the collaborative filtering can also be item-item collaborative filtering. The idea is very similar to what we just discussed. It's just instead of finding the similarity between users, we find the similarity between items. And then we see that what are the ratings given by x to those items, and then we take the weighted average of those ratings. In practice, item-item collaborative filtering performs better because items are simpler than users, and item similarity makes more sense than user similarity. So mathematically, the predicted rating for user X for the movie M would be sigma rating of X given by X to movie Mi into similarity between M and Mi divided by sum of similarities between M and movie MIs, where I can range from 1 to k, let's say. So that's the end for today's interview question, what is collaborative filtering? If you liked the video, don't forget to like, share and subscribe as more videos are coming soon. Good time until then.